Hi students, today we are going to discuss how to find out the bond order of a molecule within seconds. Bond order related questions normally in every year, that type of question coming in NEET, JEE, sometimes even for CSIR NET exam. How to find out the bond order of a molecule within few seconds, that we are going to discuss today. So we know that the equation for bond order, half into number of electron in bonding molecular orbital minus number of electron in anti-bonding molecular orbital. Okay, we are doing this calculation. For example, in case of O2, half into number of electron in bonding is 10, number of electron in anti-bonding is 6, 10 minus 6, that is 4 by 2 is equal to 2. It means oxygen, oxygen, what bond? Double bond. Bond order means how many bonds between two atoms in a molecule, that is actually bond order. Similarly for nitrogen, half into 10 minus 4, bonding contain 10, anti-bonding contain 4, then it will be 3, so nitrogen, nitrogen, triple bond in N2 molecules. Similarly for hydrogen, half into 2 minus 0, this is equal to 1, then hydrogen, hydrogen, single bond. If bond order is 1, single bond. If bond order is 2, double bond. If bond order is 3, triple bond. If bond order is negative or 0, such a molecule does not exist. Okay, now if bond order is in between 1 and 2, it has partial double bond character. If it is in between 2 and 3, suppose fraction, for example 1.5, some cases the bond order will be what, 1.5. okay, so it means what, that has partial double bond character. If it is in between 2 and 3, it has partial triple bond character. But this method is a time consuming process. Why? Because how to find out the number of electron in bonding and anti-bonding, it is time consuming. Okay, so normally we have 1 minute for one question. Okay, so if you follow this normal method, you can't answer in the prescribed time. Okay, you can't finish. So we are giving some tricks, very useful tricks. Any question related to bond order, if comes in that type of exam, we can solve that very easily. Okay, ഏത് എക്സാമിലും ബോണ്ട് ഓർഡർ റിലേറ്റഡ് ആയിട്ട് ഏത് ക്വസ്റ്റ്യൻ വന്നാലും വളരെ പെട്ടെന്ന് എങ്ങനെ സോൾവ് ചെയ്യാം എന്നുള്ള ചെറിയ ട്രിക്സ് ആണ് ഞാൻ ഇവിടെ പറയാൻ പോകുന്നത്. ഓക്കെ, വി ക്യാൻ സീ ഹൗ വി ക്യാൻ ഡിസ്കസ് ദ Okay, now we are going to discuss the bond order of some diatomic molecule like O2, B2, N2, O2 plus, O2 2 plus, O2 minus, O2 2 minus, CO. This type of molecule, we have a trick. In this trick, we are counting the total number of electron. If the total number of electron is 10, bond order is 1, single bond. If the total number of electron 11, bond order is 1.5, that is partial double bond. Total number of electron 12, bond order 2, double bond. Total number of electron 13, bond order 2.5, partial triple bond. Total number of electron 14, bond order 3, triple bond. Again 15, 2.5, 16, 2, 17, 1.5, 18, 1. Okay, so we can see how we can calculate this. In case of oxygen, we know that atomic number of oxygen is 8. 2 oxygen, therefore the total number of electron is what, 16. 16, bond order is what, 2, that is oxygen, oxygen, double bond. Now in case of boron, atomic number is 5, total number of electron will be 10. If it is 10, bond order 1, that is boron molecule, boron, boron, single bond. Now N2, atomic number of nitrogen 7, total number of electron is what, 14. Then bond order 3, that is nitrogen, nitrogen, what bond, triple bond. Now in case of O2 plus means what, oxygen 16, then plus 1 means 1 electron is removed. 1 electron remove edittundu. So the total number of electron is what, 15. Then 15 means bond order 2.5, partial triple bond. O2 2 plus 2 electron is removed, so it is what, 14. 14, it will be what, 3, that is O2 2 plus have what bond, triple bond. Now O2 minus, O2 16 minus means one more electron is excess. So what will be the 17. 17, 1.5, that is partial double bond. O2 2 minus, it will be what? 18. Then bond order will be what? Bond order will be 1, that is single bond. Now in case of carbon monoxide, carbon atomic number 6 and oxygen 8. 8 plus 6, that is 14. 14, it will be what? 3. We know that carbon monoxide, carbon oxygen, it is what? Triple bond. So this is the trick to find out the bond order of some diatomic molecules. Now in case of polyatomic resonating molecules like carbonate ion, this method is not applicable. We have another trick for this type of molecule that we are going to discuss now. Now in case of polyatomic resonating molecules like carbonate ion, sulfate ion, okay, this type of molecule, how we can find out the bond order? For this we have an equation, that is number of resonating bond divided by number of resonating structure. For example, carbonate ion. Carbonate ion, the Lewis structure, we know what is the Lewis structure of carbonate ion. This is the Lewis structure of carbonate ion. Okay, so number of resonating bond, how many bonds are there? 1, 2, 3, 4. Okay, so number of resonating bond is what? 4. Divided by number of resonating structure. So see, this bond shift here, then this will shift here, then we will get a resonating structure O minus. Here what? Double bond, here. Okay, now again what happens? This shift here, then this bond shift here. So we are getting another resonating structure. So total how many resonating structure we got? 3 resonating structure. Okay, so it will be 4 by 3 divided 4 by 3 is equal to what? Bond order is what? 1.33. Now listen here. Here the number of resonating structure is equal to the number of peripheral atom. What is the number of resonating structure here? 3. How many peripheral atom here? 3 peripheral atoms here. So the resonating structure always number of peripheral atom. Now one more thing, in this type of species, the negative charge, the charge, that is negative charge on the species equal to the number of single bond. See how many single bond here? 2 single bond. What is charge here? 2. In case charge 2 ആണ്, 2 single bond ഉണ്ട്. Okay. അപ്പോൾ ലൂയിസ് സ്ട്രക്ചർ വരയ്ക്കാൻ ഒരു എളുപ്പമാണ്. ഇത് നോക്കി നമുക്ക് എത്ര സിംഗിൾ ബോണ്ട് എന്ന് കിട്ടും. ഓക്കെ, ഇനി നമുക്ക് സൾഫേറ്റ് അയണിലേക്ക് വരാം. സൾഫേറ്റ് അയണിലേക്ക് വരുന്ന സമയത്ത് എന്തായിരിക്കും? സൾഫേറ്റ് അയണിൽ നോക്കൂ, സൾഫേറ്റ് അയണിൻ്റെ സ്ട്രക്ചർ ഇങ്ങനെയാണ്. ദ സ്ട്രക്ചർ ഓഫ് സൾഫേറ്റ് അയൺ. This is the structure of sulfate ion. See, 2 charge, 2 single bond. Okay. Now here total number of bond is what? 1, 2, 3, 4, 5, 6. So 6 divided by total number of resonating structure. Double here, one double here, then another structure. One double here, that is another structure. That is one double here, that is this shifting here, this shifting here. So double here. In this way we will get how many structure? 4 structure. So 4 by 6 by 4, that is equal to what? 3 by 2, that is 1.5. Now in former case, carbonate and listen here, we got what? 1.33. How many sigma bond or single bond here? 1, 2. How many double bond? 1 double bond. See, if double bond order is what? 2. If single bond order is what? 1. So if double and single comes, the bond order will be in between what? 2 and 1. If equal number of double and single, bond order will be what? 1.5. Here how many single? 2 single and 1 double. It's not equal. So which one will be more? That is double is more. So the bond order will be close to that one. The single bond order is what? 1. How many single? 2 single. So the bond order will be what? In between 1.5 and 1. In this case, how many single? 2 single, 2 double. So it will be exactly what? 1.5, because number of single bond and number of double bonds are what? Same. Okay. So that is
in case of sulfate ion and carbonate ion. Okay, in this way we can find out the bond order of any such molecule resonating structure. Okay, so here also we have some difficulty, that is we should know the Lewis structure or resonating structure, then only we can find out the bond order. Okay, so it is very difficult to remember all the resonating structure, so we have another trick, very easy trick. By that trick we can find out the bond order of all these molecules, no need of what Lewis structure or resonating structure. Without that we can find out the bond order that we are going to discuss now. Okay, അതായത് ഈ രൂപത്തിൽ നമുക്ക് ബോണ്ട് ഓർഡർ കാണണമെങ്കിൽ ആ മോളിക്യൂളിൻ്റെ റെസനേറ്റിംഗ് സ്ട്രക്ചർ നമുക്ക് എന്ത് ചെയ്യണം, അറിഞ്ഞിരിക്കണം. എന്നാൽ പലപ്പോഴും നമുക്ക് എന്താണ് റെസനേറ്റിംഗ് സ്ട്രക്ചറൊക്കെ വരച്ച് കാണാൻ എന്താണ് ബുദ്ധിമുട്ട് തോന്നും. ഓക്കെ, കാരണം വളരെ കുറഞ്ഞ സമയം നമുക്ക് എക്സാമുകളിൽ കിട്ടുകയുള്ളൂ. അതുകൊണ്ട് വളരെ എളുപ്പത്തിൽ ഇങ്ങനെയുള്ള മോളിക്യൂളിൻ്റെ ബോണ്ട് ഓർഡർ നമുക്ക് എങ്ങനെ കാണാം എന്നുള്ളതാണ് നമ്മൾ അടുത്ത് പറയാൻ പോകുന്നത്. ഓക്കെ, ഇവിടെ നമുക്ക് ഇതേ മോളിക്യൂൾസിൽ തന്നെ ബോണ്ട് ഓർഡർ വേറെ ഒരു ഷോർട്ട് കട്ട് മെത്തേഡിലൂടെ കണ്ടെത്താം. ഓക്കെ, so how we can find out the bond order of this molecule in simple way? See, here we have an equation, valence bond order is equal to valency of the surrounding atom plus charge on the acid radical or radical and a number of surrounding atoms or peripheral atom. So the molecule like acid radicals like CO3 2 minus, SO4 2 minus, SO4 3 minus, PO4 3 minus, okay, this NO2 minus. Okay, all these type of what acid radical we can find out by using this equation. See, we can take first example, CO3 2 minus, which is the peripheral atom or surrounding atom oxygen. Valency of oxygen we know that, what 2 plus charge on the radical what minus 2 divided by number of peripheral atom is what 3 into 2 6 minus 2 4 by 3, that is what 1.33 is the bond order. Already we got in former method. Now SO4 2 minus, again surrounding atom is what oxygen, valency is what 2 and charge is minus 2 and the surrounding number of atom is what 4 into 2 8 minus 6 8 minus 2 6 by 4 is equal to 1.5 that we got. Now SO4 3 minus, here surrounding atom oxygen valence is what 2 plus charge minus 3 divided by number of surrounding atom 4 into 8 minus 2 s minus 3 5 minus 5 by 4 is equal to 5 by 4 is equal to 1.25, that is the bond order. Okay, so by using this equation no need to find out the Lewis structure, no need to draw the Lewis structure. Without Lewis structure we can find out the bond order. ഈ ഇക്വേഷൻ ഉപയോഗിക്കുകയാണെങ്കിൽ ലൂയിസ് സ്ട്രക്ചർ അറിഞ്ഞിട്ടില്ലെങ്കിലും നമുക്ക് എന്ത് ചെയ്യാൻ പറ്റും, ഒരു മോളിക്യൂളിൻ്റെ ബോണ്ട് ഓർഡർ കണ്ടെത്താൻ പറ്റും. ഓക്കെ, ഇതിന് ഇനി കുറച്ച് എക്സാമ്പിൾസും കൂടെ ഞാൻ തരാം ഈ മെത്തേഡിൽ. ഓക്കെ, ഞാൻ അതിൻ്റെ വാല്യൂ ഇവിടെ എഴുതാം, അതിൻ്റെ കറക്റ്റ് എന്താണ് എത്രയാണ് ബോണ്ട് ഓർഡർ നിങ്ങൾക്ക് എന്ത് ചെയ്യാം കണ്ടുപിടിക്കാം.
C of the peripheral atom, that is oxygen peripheral atom is 2, then charge minus 3 divided by number 4 into 8 minus 3 5 by 4, that is equal to 1.25. Similarly, if you find out the bond order of all this type of oxygen based acid radical, we can find out the bond order very easily. Okay, so this is the trick to find out the bond order of polyatomic resonating molecule like this type of oxygen based acid radicals. Okay, now there are some examples. See, for example, see nitrate ion. Can we find out the bond order of nitrate ion by using this method? Okay, nitrate NO3 minus. So if we use this equation, what we will get? Surrounding atom oxygen, valency 2, then plus charge minus 1 divided by number of surrounding atom 3 into 2 6 minus 1, that is 5 by 3, that is equal to 1.66. This is wrong. That is not the bond order of nitrate ion. Instead, the bond order of nitrate ion is what? 1.33. So this equation is not applicable for nitrate ion. Why? Because the structure of nitrate ion, when we see the structure of the nitrate ion, this is the structure of nitrate ion. This is the structure of nitrate ion. Actually, we had an hydrogen here. Then hydrogen is removed. HNO3. From HNO3, when hydrogen is removed, then this oxygen got what? Negative charge. Okay. Now that's why here it is what? 6 electron, and one here total 7 electron. That is 1 electron came from what? Hydrogen. But in this case, you can see the 6 valence electron of oxygen is here. Okay. So in this bond, these both electron belongs to what? Nitrogen atom. It means this bond is a dative bond or coordinate bond. Okay, a bond in which both the shared pair of electron belongs to one of the bonded atom is called dative bond or coordinate bond. So this is a dative bond. Okay, so only this charge we are considering here. For this molecule, if you calculate the formal charge, this oxygen also will get a negative charge. Okay, that means if dative bond is present in the molecule, the formal charge of the peripheral atom also we have to consider. So charge will be what here? -2 instead of what? -1. Because this one will have -1 charge if you calculate the formal charge. So what will be 2 plus -2 divided by what? 3. Then 3 into 2, 6. 6 minus 2, 4. 4 by 3 is equal to what? 1.33. This is the bond order. Okay. Then old method also we can use. See here how many bonds are there? 1, 2, 3, 4 bond. So 4 bond. Resonating structure is what? This double bond may shift here. So one resonating structure, and this double bond may shift here. So 2. Then this one itself. So total how many resonating structure? 3 resonating structure. So 4 by 3. That is what? 1.33. Okay, so remember, if the molecule contains dative bond or coordinate bond, in such a molecule we have to consider the formal charge of the peripheral atom. Okay, one more example of this type. What is that? Sulfur dioxide. Sulfur dioxide is another example. In case of sulfur dioxide, the structure is what? Sulfur dioxide structure is what? This is the structure of sulfur dioxide. The valence electron of sulfur is 6. So here it is what? 4. Here it is 6. This is the valence electron. So this oxygen has 6 valence electron. Then which electron involved in this bonding? That means in this bonding both electron belongs to what? Sulfur atom. It means this bond is a dative bond. In this dative bond we have to consider the formal charge. It means this one will have a negative, this one will be a positive. Only this peripheral atom formal charge we have to consider. So normally if you calculate bond order is equal to what? Peripheral atom valency 2 plus there is no charge on this 0 divided by 2 peripheral atom 2 into 2, that is what? 4 by 2, that is 2. 2 is the bond order, but it is wrong. We have to consider this negative charge because here we have dative bond. So bond order is what? 2 plus charge is what? -1 divided by 2. 2 into 2, 4. -1, that is 3. Then 3 by 2 is equal to 1.5. So this one have what? 1.5. I told you that one single, one double. That is, if number of single bond and double bond is same, the bond order will be what? 1.5. That is in between 1 and 2. If only double bond, bond order 2. If only single bond, bond order 1. If same number of double bond and single bond order will be what? 1.5. Also, the old method we can calculate. See, total number of bond is what? 1, 2, 3. 3 bonds divided by resonating structure. This double bond may shift here. So one structure, this one, and if you shift here, you will get another structure. So total how many structure? 3 by 2, that is what? 1.5. It's okay. Similarly, in these are two what exception, that means remember, if dative bond is present, what we have to do? Formal charge of the peripheral atom also we have to count. Okay, then only we will get the correct bond order. Example, NO3 and SO2. Okay, now one more example, CO2, carbon dioxide. This we can find out directly because here we have no what dative bond. See, carbon dioxide is a linear molecule, C double bond O, C double bond O. Total how many resonating structure? Total how many bonds? 4 bond. How many resonating structure? This may shift here, so we will get what? O minus plus double bond. So resonance structure. It's okay. Then one is what? Here also may shift. So total how many resonance structure? 2 resonance structure. 4 by 2. That is what? 2. Both bonds are what? Double bond. So bond order is what? 2. So in case of carbon dioxide, bond order is 2. Sulfur dioxide, bond order is 1.5. Now sometimes question paper may contains questions like see, find out the bond order of oxygen in hydrogen peroxide. Find out the bond order of oxygen in hydrogen peroxide. How we can find out it? See, here in this case, remove the H plus. Remove H plus. If you remove H plus, you will get what? O2 minus. O2 minus, the total number of electron is what? 18. Then bond order is what? 1. That is single bond. Sometimes question may come like this, KO2. In case of KO2, what is the bond order of oxygen? Remove the K plus. If you remove the K plus, it will be what? O2 minus. That means total number of electron is what? 17. If total number of electrons 17, I told you that what? The bond order is what? 1.5. Partial double bond. Okay. So these are the some easy method to find out the bond order of molecule. Normally this type of questions normally asking in JEE and in NEET exams. Okay. Now more about the chemical bonding we will discuss in next video. Thank you for watching.